Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out with these uniform motion problems, and the one we're going to look at here is number 10 on your handout here. And it says a passenger train travels 165 miles in the same time as a freight train travels 120 miles. The passenger train is 15 miles per hour faster. Find both rates. So what you want to do with these problems is consider both trains here, and I'm going to kind of label them here. I got passenger train on the left, freight train on the right, and we're going to be using the following formula, that distance traveled is equal to rate times time. This is true for both trains. So the passenger train travels a distance of 165 miles in the same time that the freight train travels 120. That's an important thing. A very important thing to realize is the unknowns. The unknowns are the two rates, so I'm going to let R equal the rate of the passenger train. Now, you'll notice that it says the passenger train is 15 miles per hour faster than the other train. So if this one is R, then the other one is going to be R minus 15. Now, we could also define R as the rate that the freight train travels, and then the passenger train would be R plus 15, and it won't matter which. Right? So now, applying this formula to the passenger train, the distance is 165 miles. I'm going to leave the units out of this, right? Times the rate R times T. Now, this equation has two unknowns, so we just leave it alone, we move on. We come over here, we apply the same formula. The distance equals rate times time. Our distance is 120 miles. Equals, our rate is R minus 15. And then, again, times T. So, what we have now is a pair of equations here. Equation 1, equation 2, with two unknowns. There's a couple ways to solve these. We could use good old-fashioned substitution, like, for example, if I solve this for t, that would equal 165 over r. Now, anywhere we see a 165 over r, or I'm sorry, anywhere we see a t, we can sub 165 over r. And I see a t right here. So I'm going to go ahead and do that, continue on with substitution. So we're going to take this value and place it in here, rewrite our equation. This is now going to read 120 equals r minus 15 times t, which is equal to 165 over r. Now, our equation now has a fraction, which is fine. I'm going to use kind of the standard get rid of fractions approach. We can get rid of the fraction by multiplying both sides by r. Now again, if you do one side, you have to do the other. All right, over on the right, these are going to reduce. New line. Let's write that 120r equals. Okay, this 165, let's go ahead and distribute it. So this term is going to be 165r minus, I'm going to take a moment here and calculate that other term. All right, so 165 times 15, I got 2475. Right, now we want to get the r's together. One way we can do that is by subtracting 165r from both sides. Always have to do both sides. Right, so this left-hand side, we're going to have minus 45r equals. Right-hand side, these are going to add to 0. We're just left with minus 2475. Next step to solve for r, we're going to divide both sides by minus 45, so this is going to read minus 2475 over minus 45. And you give me a moment here. All right, I get 55 miles per hour. All right, for the value of r, which is the rate for the passenger plane. And then our train. Our freight train here is traveling at r minus 15, so I think that's going to be 40 miles per hour. coming from 55 minus 15. So I hope that this video helps demonstrate how to set up these equations. Again, the big thing is that, when you got two objects, make sure and kind of take them one at a time. In this case, a passenger train and a freight train, or maybe sometimes it's a car and a boat, or a car and a train, or whatnot. Make sure you figure out what the unknown is and let your variable, define a variable to represent it. So in this case, like I let R equal the rate of the passenger train. Could have just as easily let R equal rate of the freight train. That won't matter. Once you define a variable, though, look around and see if you can then write down another variable in terms of it, like I did right here. Then you're just applying this formula, distance equals rate times time, to both objects. In this case, the passenger train and the freight train. And then usually there'll be some sort of algebra equation where you have to eliminate an unknown. So hope this video helps demonstrate these concepts. Have a great day.